We've all had the experience of only really understanding something after we had to teach or explain it to someone else. MathCraft is a new kind of video game built on that learning by teaching premise. It helps build a deeper understanding of middle school math by reversing the usual roles of the player and the computer. You are the tutor and must help an on-screen character, Elle, who is struggling to survive in a harsh sci-fi world. Many of the in-game situations and challenges can best be handled by modeling them as math problems. If you ignore those opportunities to use math, you'll often waste resources or create more problems for yourself later in the game. Our AI system, Psych, puppet masters Elle so that he or she is always just a little more confused than you are. As you demonstrate deeper understanding, Psych allows Elle to make fewer mistakes of that kind. So, from your point of view, you're teaching Elle. Psych knows the common sorts of mistakes people make as they work with fractions, linear equations, ratios, interest rates, and so on. So Elle's mistakes, and Elle's appearing to learn as you tutor her, are very much like interacting with a real human being. In the sci-fi adventure, you communicate over a mental link to Elle, a robot who is on a crashed starship light years away. We'll see some in-game motivation for setting up and solving particular math problems in a minute, but here the player is watching as Elle struggles to evaluate the expression 4x minus 3 when x is 7. Elle shows her work and explains her thinking in chat-like messages. And you have the opportunity to give Elle tutorial feedback at certain critical points. Behind MathCraft's flashy graphics and engaging gameplay, Psych is keeping track of how well you know each of the relevant concepts and skills and where your knowledge gaps are. We found it necessary to track about 500 separate user competencies. Everything you say and do impacts Psych's dynamic model of you. Did you fail to correct her when she made a mistake? If you did correct her, was it heavy-handed? Or did you give her wise advice to help her understand what she did wrong and why? Did you mistakenly correct Elle when she was on the right track? In this case, Elle misunderstands the relation between a coefficient and a variable. She thinks that when x is 7, 4x means 47. What's going on here? We've logged in as Cheyenne, a 7th grader who makes this kind of mistake sometimes. Psych knows that. The relevant user model element tells Psych that. So Psych is directing Elle to make that mistake, to see whether or not the player, Cheyenne, notices this error. Psych has inferred that this is the best thing for Cheyenne to see. Right now, this will give Cheyenne the best learning experience. Cheyenne could say okay and let Elle make this mistake, or realize that this is wrong and correct Elle. Here's a different student, Barry, who gets to the same point in the game, working on the very same problem. Barry rarely makes the appending mistake, so Psych has had Elle set up the problem correctly as 4 times 7 minus 3. There might be some opportunity for error coming up soon because Barry sometimes gets confused about the order of operations. But wait. Oh no! Barry has regressed a bit and miscorrects Elle, telling her to append 4 and 7 after all. The math finishes. Barry has his answer, 47 minus 3 is 44. He tries it out, and, since it's the wrong answer, it doesn't work. The door doesn't open. Barry knows that he and Elle got the wrong answer. Psych knows exactly what the mistake was, of course. So Psych has Elle fortuitously remember a similar problem which will be exactly what Barry needs to get him to see the error of his ways. Psych has Elle remember that she once did a similar problem, evaluating 1/2 x when x equals 4. Just try to append the 4 here. It's hard to do. Barry remembers that multiplication is supposed to happen here, not appending. Barry and Elle now go back to the in-game problem that matters, 4x minus 3 when x equals 7, and this time he doesn't miscorrect Elle. They get the right answer, and, in this case, the door opens. With MathCraft's Teacher Dashboard, teachers can examine detailed records of what their students have been doing in the game, and can sort their classes into groups, which each could use some extra help in certain areas. The teacher can examine an individual student's strengths and weaknesses. Teachers can examine the full history of problems that each student has worked on in the game. And if they wonder why some element is so high or so low, they can even drill down further and see which specific actions or inactions of berries cause that model element to go up or down. In this case, the model element is one that avoids the appending error. At a meta level, the game reinforces the usefulness of knowing when and how much to estimate, finding creative, alternative ways to attack an otherwise familiar problem, when it's cost-effective to check your answer, for instance, you have to backtrack and remeasure something in the game, and it reinforces that actions have consequences. Game saves are frequent, but students are not authorized to reload any of their saved games. If you skipped modeling a game situation as a math problem, or you got the wrong answer, and you did something unfortunate in the game world,
pretty bad. At least it's not leaking anything. Computer, what are the consequences of this big water leak?
None.
Phew!
Until this compartment is completely filled with water. At that time, protective fields will fail. Cargo deck will be jettisoned to protect ship integrity. Planetary mission will be impossible to complete.
You just have to dig yourself out of that hole, sometimes literally. The player can now do some math to figure out what diameter object is needed to plug up this leak they just caused, or continue to eschew doing math and spend 10 times as long using trial and error until they find one that works. Students can't reload saved games, but teachers can, and we can. So let's reload to the point where Barry ignored the warning signs about the deck only supporting 70 pounds per square inch, and impulsively just opened that claw up. This is part of a quest where Elle needs to find the black box on the starship to prove to the authorities back on Earth that she's not responsible for the crash. Barry wants to free up the claw so he and Elle can use it to dig out the black box nearby. Elle finds out about the container. It's made of lead, which has a certain density. The container has a certain length, width, height, and so on. Barry and Elle can use some of these numbers to calculate how many pounds per square inch the container would exert on the floor if it was resting there. In many of the problems in the game, Elle and the player have a chance to decide how to set up the math problem. This particular problem can be set up in at least two very different but correct ways. Elle can multiply the density of lead and the height of the container, or Elle can divide the weight of the container by the surface area of its base. Different players with different user models would see different problems right here. They might look similar in-game, but the dimensions of the container might have fractional parts or decimal fractional parts, or might be given in metric units and have to be converted to English ones, and so on. For instance, if the student has no idea about unit of measure conversion, including it would just confuse them, so Psych doesn't do that. And at the other extreme, if the student has 100% mastery of unit of measure conversion, including it would just waste their time. But if they're close to 50-50, then Psych might very well add in that wrinkle to the situation for that student. After completing any math problem, the player can review it. During the review, at each point at which the player gave Elle tutorial advice, Psych will show whether the advice was right or wrong, and Psych will indicate how the advice affected the player's score, along with any of the 4 main user model components. Did the advice make the player seem like a better tutor or a more adventurous explorer? More knowledgeable about math concepts or more skilled at math algorithms? Seeing this feedback right after working through the problem can help motivate the player to improve each of these scores.
Bummer. It's a little too heavy. We'll need to find another way to get the black box.
Barry and Elle got the right answer. The cargo container is too heavy for the floor. They should just decide to move on to find a different solution to the in-game challenge. They could eventually go to the vehicles deck and chemically mix up some airbot fuel and send an airbot to fly over to where the black box flight recorder is. Or they can say, to heck with what the math said, let's just gently lower it to the deck and let go of it, and hope for the best. Uh-oh, they should have trusted the math. Elle and the player have shorted out the claw, and they learn that the water leak they just caused may even jeopardize the starship's mission. Not only is this compartment filling up with water, it's nutrient-enriched water that's needed elsewhere on the ship to keep the hydroponics working, so that the plants, which were brought from Earth, don't die. Depending on the student's model, Psych will present different sorts of information, which in turn enable different possible approaches to calculate how long until the chamber fills with water. Barry and Elle determine that they have about 1 hour until the chamber fills. This is a good example of the power of estimation. You get your answer in a few seconds. It's not worth taking an extra 3 minutes to solve that problem exactly and find out that you had 1 hour and 2 seconds until the chamber fills, but by then you have only 57 minutes left because you chose not to estimate. Barry and Elle need to calculate the interior circumference of the pipe that's leaking water, so they can find the right-sized object to plug it up. Many problems in the game are accompanied with graphics that help explain the nature of the challenge. Here, the player and Elle are shown a depiction of the pipe, showing its exterior diameter and the width of the pipe material. Because of Barry's current level of comfort with unit of measure conversion, Psych decides to give him this in centimeters. In either case, with this problem, it's important for the players to notice that they should apply the formula for finding the circumference of a circle given its diameter, and they also need to realize that it's the interior circumference that matters, so they need to subtract twice the thickness of the pipe from the exterior diameter. This is a common mistake, to forget that factor of 2. Once Elle knows the circumference of the pipe interior, Elle and the player need to find an object that's the right size to plug it up. The player needs to be careful not to have Elle spend too much time in the water, because electrically powered robots and water don't mix. Elle's power level is just one of many limited resources that the player has to help Elle manage in order to be successful in the game. Actions have consequence, remember. The lessons are harsh, but never quite fatal since the player can't reload. Running out of power, for instance standing around in the water much longer than you need to, means that Elle will have to move very slowly over to a recharging station, and some of Elle's abilities, such as to sense nearby interactable objects, won't function until she recharges.
Just what the doctor ordered.
There! Plugging the pipe has slowed the leak significantly, but not completely. Math tells them they now have about a day to fix the slow leak that remains. Once Elle and the player have the pipe leak under control, it will be time to move on, to find another way to retrieve the black box, to restore main ship power for the communication array, maybe find and repair a pet bot, maybe clear out a safe home lair area, leave the ship to explore anomalies on the planet, and find the automated alien defense systems that actually shot the starship down, and all the other major and minor adventure quests that await them in MathCraft.